All right, what is up, everybody? Welcome to day one of the EOG geometry review. As always, a little bit of a warm-up, some guided notes, and then a practice at the end. So number one from the warm-up, we have 3 times x plus 6, all being divided by 4 is the same as 15. First thing we need to do is break up the problem so that we have 2 fractions that equal our sum. So 3 over 4 times x plus 6 over 4 is the same as 15 is how we'll set that problem up, because it's 3 over x, 6 over x, 3 over 4, 6 over 4, everything is over 4. Once we have it set up, first step, we have plus 6 over 4. So the first step is to subtract 6 over 4 on both sides. 15 minus 6 over 4 is 13.5. We drop down 3/4 times x. We divide each side by 3/4 because we have 3/4 times x is the same as 13.5. And when you divide each side by 13.5, you're going to find out x equals 18. We can easily check our work. We plug 18 in for x, 3 times x plus 6, all being divided by 4 will give you 15. And once we know that 15 is the same as 15, we can move on about our problem. Number 2, a real estate agent makes a salary of $900 per month. So we already know no matter what they do, they're going to get that $900. She also makes 2% from each house she sells. Right here, they talk about selling a house for $125,999. We want to see the total amount of money that she made. Well, we got to think. We know we're getting all of the $900. She gets that no matter what she does. She also gets 2% for everything she sells. She gets 2% of everything she sells. So the first thing, we got to figure out how much the commission was. We take the $125,999 times the 2%. We end up, she made $2,519.98 for selling that house. That's her commission. That's what she gets to keep from that house. In addition to that, she also gets her salary. So we're going to take the commission plus her $900 salary. It means that she made a grand total of $3,419.98. Letter choice D. So when we get to this, it's always the commission plus the salary gives you your total. Again, she gets a piece of the house and she gets to keep all of her salary. Number 3, circle X has a circumference of 250 meters. What is the approximate radius? Okay, well, I have to think. I know this is definitely a circumference problem because it literally says the word circumference. So I know my formula, C equals pi d. Well, in this problem, I got to think to myself, what other information did they give me? They only gave me the circumference. So I could say that 250 is the same as pi times the diameter because we know the circumference, we just don't know the diameter. So we really have a one-step equation. Since we have 3.14 times the diameter, we can divide each side by pi. 250 divided by pi will give me the diameter of 79.5. But this question wants to know the radius. Well, once I know the diameter, I know the radius is half as big, so I divide by 2, and I would find out that the radius would be 39.7 meters. So again, just working backwards. Number 4, determine the surface area of the figure shown below. So here's our figure. We have a rectangular prism. Well, there's 6 sides to all rectangular prisms. They're kind of like a shoebox. We have a front, a back, a left side, a right side, a top, and a bottom. So the first thing we need to do in this problem is literally break it apart. So again, all I did was take the 6 sides and I broke them apart and labeled them. Front, back, left side, right side, top, bottom. That helps you keep your work nice, neat, and organized. After that, I would take your pen or pencil and just kind of trace over the problem to see, well, what are the dimensions? Let's try the front. The front, as I go past the front, I go by 12. Well, I have nothing on the sides here, but I know that this 4 is parallel to that line. So the front must be 12 times 4, which is 48. And again, anything in geometry that is symmetrical or opposite or congruent, they're the same. So if the front is 48, the back is 48. Next up, I'll take a look at the left side and the right side. Well, the left side is a little tough because they didn't really give me the see-through dimensions on this. So again, I'd have to look at the right side and see if there's any numbers that'll help me. Well, as I trace the right side, I go past 4 and 4. The left side and the right side are the same, so I know that they're both going to be 4 times 4 or 16. Last part I got to figure out, top and bottom. Again, top, if I trace the top, there's nothing really there, so I'd have to take a look at the bottom on this. And again, since I know that they're congruent, they'll be the same. Well, when I trace the bottom, I go by 12 by 4. Again, that's another 48. And again, the top and the bottom are going to be the exact same. Once I have all the areas of each piece, last step is to add them together. So 48 plus 48 plus 16 plus 16 plus 48 plus 48. The front and the back plus the left side, the right side, the top, the bottom. You end up with 224 units squared. All right, again, if you have to pause the video, go back through and copy any notes you can. All right, moving on today. Again, we got our bit.ly for our notes, and then we also have our problematic bit.ly at the end. I think it's only about 8 to 10 questions this week. All right, first up, our little daily dose of algebra. We're going to do some inequality review this week for our daily dose. So, first up, got to know our symbols. We have less than because it looks like an L. We have less than or equal to. That line underneath lets us know that it's less than or equal to. We have greater than, and then we have greater than or equal to. First thing you might want to remember is what circles are they? Anything that's less than or greater than gets an open circle. Anything that is or equal to, less than or equal to, greater than or equal to gets a filled in circle. So, on the board, we have n is greater than or equal to -4. So again, we know our graph's going to start at -4 because that's where the problem tells us. The first thing I would do is try to think, using a number line, what are 3 numbers that are greater than or equal to -4? Well, I always want to start with the first integer that makes that true, which is -4. -4 is greater than or equal to -4. Then any number to the right of -4 is also going to be greater. So -3 is the first integer to the right of -4, and then I jumped and I made -5. Again, when I go to plot these on my number line, I know I'm starting at -4 because that's where the problem told me. I know -3 is to the right, and I also know 5 is to the right. Last part, I got to think, well, I have greater than or equal to. That would be a closed-in circle, and we're going to shade in the direction of our solution set, which would be to the right. If you want to pause the video and try number 2 and number 3 on your own, go ahead, and when you're ready, unpause, and I'll go over them. So, number 2, we have x is less than a number. X is less than a number. Again, first thing I would do, make a solution set. Because then, again, you know Pac-Man's eating the greater thing, so he's eating x. So if you thought that this, just because of this symbol less than, like 4, 3, 2, 1, 0, and all the negative numbers were true, you'd have to just say it in your head. Is 5 less than 4? No way. Is 5 less than 0? Is 5 less than any negative number? No way. So we're actually looking for greater than numbers. Is 5 less than 6? Yes. Is 5 less than 7? Yes. 5 less than 10? Those were the 3 numbers I came up with. I know, again, 6 is to the right, 10 is to the right. This time, I have just a less than symbol, which is going to be an open circle starting at the number 5. And again, I'm going to shade in the direction of my solution set. And last one, number 3, n is less than 6. Pretty easy stuff. 3 numbers that are less than 6. Well, the first number is 5. The next number would be 4. And then you could think any negative number would be less than a positive. So again, 5, 4. And I'll go ahead and put -6 way over there. Again, I have less than, same symbol as above. The only difference is this time these numbers are to the left of +6. So again, know your symbols and use a number line to help you create solution sets. That way the graph part becomes very easy. All right, today we're going to be going over some geometry stuff. So first thing I would do, make sure you know all your formulas. On the paper, I got spots for you. So area of a circle, pi times its radius to the 2nd power. Area of either squares or rectangles would be length times width. Area of a triangle, 1/2 base times height. Circumference of a circle, the distance around the circle, pi times diameter. And then volume is the area of the base times the height of the prism. So really it's a couple different things. If it's a rectangular prism, you got length times width times height. If it's a triangular prism, we have 1/2 times the base of the triangle times the height of the triangle times how tall or the height of the entire prism. Okay, today we're going to be doing a little bit of a circle review. So, take a minute if you want, give these easy ones a try before we get into some trickier ones today. First up, this one on the left. I have to think, what information did they give me? 6.5. Well, it starts in the center and it only goes to the edge. So that's my radius. The radius is the smaller line, it's the smaller word, it has the smaller value. So 6.5 is my radius. My diameter is twice as big because if I was to draw it, it would go all the way through the circle. It's twice the radius, so 6.5 times 2 is 13. From there, the first thing I wanted to find was the circumference. Always start with your formula. That way you know which number you need to plug in. C equals pi times the diameter. Well, I have 13 listed as my diameter, so pi times 13 in a calculator, we would get 40.8. Second part I wanted to find was the area. Again, starting with the formula, pi times the radius to the 2nd power. If you write the formula, it's very easy because then you just look at your radius and diameter and see which number do I got to plug in. In this case, it's pi times 6.5 to the second power, and when you put that in a calculator, you would get 132.7. Okay, so right there, again, circumference, area, always, always, always start with your radius and diameter, start with your formula, and then go from there. Second one, well, this time I gave you a line that goes from one side straight through the middle to the other side. That would be our diameter. Again, if I wanted to draw my radius, it would be half as big because it only goes to the center to the edge. Again, first thing, circumference, pi times diameter. Pi times 17 is my diameter. Put that in a calculator, you get 53.4. Remember, usually try to keep one decimal place to help you out with the circle stuff. And then secondly, we have our area, pi radius squared. Again, I have my radius already sitting there waiting for me, so it's pi times 8.5 to the second power. You put that in a calculator, you get 226.9. Again, something easy like that. Just as long as you're doing the pre-work, writing down your formulas, writing down your radius and diameters. From there, you pick up a calculator and you do your calculations from there. But again, it's really important that every single circle problem you see is either area or circumference formulas and determine radius or diameter. Start there to make the work easy. Secondly, a couple word problems to help us out. I'll help you out with these again if you want to pause the video and try them on your own. More than welcome to. So first thing, kind of like our warm-up, they tell us a circle has a circumference of 124 units, and we want to know again what would be the approximate radius. Okay, well again, the first thing I would always do, start with your formula. We know C equals pi times the diameter. Well again, think, did they give me the diameter? No. Did they give me the radius? No. They gave me the circumference. So again, I'm taking the circumference out of the formula. 124 is the same as pi times the diameter. Again, this is 3.14 times the diameter. So I can divide each side by pi, and when you do 124 divided by pi, you find out the diameter is 39.4, but you got to be careful. That's going to be one of those trap answers. Answer the question. They want the radius, so I got to divide that by 2 because the radius is half as big, and we find out that the real answer is 19.7. Okay? Second one, number 2, a bike has a diameter of 12 inches. It rotates 5 times. What is the total distance traveled? Well, this problem didn't say circumference or area, but I got to think. The tire's rotating around. It's going around and around and around. That right there is letting you know this is a circumference problem. But before I even got there, first thing I did, drew a picture. I listed what they gave me. They told me the diameter was 12 and that it's going to spin 5 times. So I put a little note here. Hey, you got to do something times 5. From there, I listed my radius and my diameter. Again, they told me the diameter is 12, the radius is 6. We determined now that this was a circumference problem. So right here, what I'm going to do is I'm going to cross out that radius just so I don't get confused and plug it into my formula. Again, circumference, pi times diameter, pi times 12. Pi times 12 is 36, but that's one rotation. In this problem, they didn't want to know 1, they wanted the total of 5. And they're even right here trying to tell you, hey, times it by 5, so 37.6 times 5 is 188.4. And last example, number 3. A large pizza at Papa John's has a diameter of 14 inches. The large pizza has a diameter of 16 inches. So right there, we have 2 different pizzas. And they want to know how much greater is the area. So again, first thing I got to take a look at. We got 2 circles. We have a pizza that has a diameter of 14 and a pizza that has a diameter of 16. Again, going through listing radius and diameter. So right here, diameter 14, radius is 7, diameter 16, radius of 8. From there, finding the area of both. Well, I don't need the diameter, even though that's the given information. I need my radiuses. Again, from there, we have area equals pi times radius to the second power. Pi 7 squared is 153.9. Pi times 8 to the second power is 201. And then they wanted to know how much greater is the area of the large pizza. That means they have a difference of 47.1. Again, the bigger area minus the smaller area. All right, from there, a couple of last problems with some combined complex figures. The math is all about problem solving, so you got to think about each problem before you kind of even go start doing any work. So read the totality of the problem. That means everything. That means the word problem, the pictures, answer choices if they're there. Okay? So first up, Coolwood Athletic Department is going to repaint a portion of the basketball court, also known as the key. What is the total area of the amount that they're going to paint? Shown to the left. Right here. First off, I recognize they are definitely wanting the total area. They want the combined area. Well, the first thing I got to think of is what shapes make up this diagram. It looks to me like I definitely have a rectangle, and then I also have this semicircle that's sitting on top of it. And again, they want the combined area, so I know I'm going to have to find the area of the rectangle and add it to the area of this semicircle. Well, first thing, how can I find the area of each piece? The first thing I did was I broke the shapes apart. So again, here's my semicircle, here's my rectangle. All I did was take them out and redraw them. So again, we have a semicircle. Right here, this line's going straight through it. That is our diameter, but we have a half circle. So again, I put a little reminder, hey, I got to divide something by 2. I redrew my rectangle. I have a length and a width of 7 and 19. From there, let's take care of the rectangle first because that's probably the easier one to go about. We have area equals length times width. Again, all they gave me was the length and the width. Pretty easy stuff. 7 times 19 is 133. Great. I know that this giant piece here in the middle is 133. But I've got to combine that with the area of the semicircle. Again, because I drew it out, this information should be pretty simple. I know that the diameter is 7. Go this way with it. And the radius is half as big, it's 3.5. Since this is an area problem, I'm going to cross out that diameter and go from there with this problem. Pi radius squared. I even put divide by 2 at the end of my formulas because, again, I have a half circle. It's been the most common mistake is people forget to take half the area. Pi times 3.5 to the second power divided by 2. I did it all straight there. We get 38.4, but again, I needed half that number. That's when I divided by 2, and I got 19.2. Last thing, they want to know the total area. Well, again, I know that I have 133 as my rectangle. I know that I have 19.2 sitting on top of it. They want to combine it for a grand total, meaning add the two together, of 133 plus 19.2, 152.2. And last one we'll take a look at today, the owner of a ice rink wants to put glass around the hockey rink. How many yards of glass will they need? Right there, they're trying to tell you the distance around this picture. Well, I know how I find the distance around a circle's circumference. That's pretty easy stuff. The only part that's a little tricky with this is I got to think, well, what part are they actually going around? And the first thing I'm going to do is highlight just the stuff that goes around. So if they wanted to replace that glass right there, that means they need 44 yards of glass. Well, down here, that's the same dimension, so they need another 44 yards of glass. But the only part I really need to calculate is the distance around these curves. And don't get tricked up by these lines. These lines are on the inside, but again, they only want to recover the outside of the glass. So again, I got to think, well, the first thing, I broke this apart a little bit, and I thought, well, I only need the top and the bottom. I put some dotted lines here just to show that, hey, that was the rectangle, but how do I find the distance around a rectangle? Well, that's perimeter. Again, they're going to need 44 yards on the top and 44 yards on the bottom. That means they're going to end up needing 88 yards of glass for the top and the bottom, the long sides. And then I had to think to myself, well, how could I use that information that they gave me? Well, it looks like I have 2 semicircles on the edges. All I did was take those 2 semicircles and put them together to make one circle, and I redrew the information. I drew my diameter, and I drew my radius, and then I thought, what does that 6 really represent? It's clearly the radius, because it's from the center to the edge. Once I have my radius, I can solve anything in this problem. Radius of 6, diameter of 12, since this is a circumference problem, because it's talking about the distance around the outside. Pi times diameter, but this time I'm not going to divide it by 2. You could if you wanted to find each individual piece, but again, 2 halves make one whole, so there's no real need to find each individual side. Circumference, pi times 12 is 36. Last part, I know that I have 88 around the distance of the glass, so again, I know that 44 and 44 is going to give me my 88. Switch back to a marker here. I know that these two 44s give me 88, and then I just found the distance around my curve is 37.6. So last part, it'd be 44 plus 44 plus 37.6. We put that in a calculator, and we'd end up with 8, 15, 165.6. All right, from there, that's everything for today. Go ahead, get your second bit.ly done. When you're done that, raise your hand, and that's it for today.